two 25 Newton weights are suspended at opposite ends of a rope that passes over a light frictionless pulley. So this is the weight, and we have two weights here. This is the rope, and this is the pulley. The pulley is attached to a chain that is fastened to the ceiling, and this is the chain, and this is the ceiling. Start solving this problem by making a free body diagram of each weight, and they ask for what is the tension in the rope and what is the tension in the chain. So this is the summary. We have weight 1, weight 2. So let's say that we have two objects here. Let's label them 1 here, and this is object 2. There are two bodies. So what is a free body diagram? A free body diagram, just like its name, is a diagram that free a body. It means that there show no body. We want to simplify it as just a point mass, just like a point. And the most important things that we need to include is the forces. Because here we want to study the motion or the equilibrium state of the object. So we need to identify the forces here. So in order to draw a free body diagram, these are the key things that we need to identify. First, we should focus on which body we're talking about. And then how many forces are there acting on that body. And then we need to identify the key elements of a force for each the force. So let's say here we have M1. And we know that everything on Earth should undergo the influence of gravity, pulling it down. So we can see that there's only gravity, weight acting on the object. What is the other forces? Here, we should looking for something that in direct contact with the body, because from there we can identify the force. And yes, we see that the rope is pulling it up, so we should have some tension. And now we have two forces, right? Weight and tension. Next, about the weight is like the earth on the object. Direction, downward. And magnitude, what is the magnitude of weight? Very familiar. mg. And here we have m1, so that's m1g. And for tension, we didn't know about the magnitude for now, so just draw some arrows upward because it points up, right? Straight up. So this is the free body diagram for M1. Done. Now, the same thing, M2. Only two forces, right? Weight, pulling it down, and then tension, pulls it up. So we got the free body diagram for M2. Now they ask for the tension in the rope. So actually we know the direction of the tension already. We need to identify the magnitude. How much? How strong is it? So the special thing about tension, about rope, is that when you have the rope unstretched, it means that it still stay in the shape. It's not this not like broken yet. So on the tension along the rope should be the same. They are equal to each other. That's why it can help to keep the rope unstretched and still stay in shape. Okay, so here we can say that we will have that the forces here. The forces, can you imagine that this is the ropes here, and then the ropes here, like on along the ropes. The tension are the same. So that's why we have that tension T1 equals to T2. And now we have T1 equal to T2 equal to the tension. The rest to identify the magnitude of this one is that we need to use the Newton's second law. So usually in this chapter we only focus on the Newton's law that apply for forces. And Newton's second law states that the F net equals to the ma. So like F is the cause of the acceleration for an object, for a body of mass m. And here we see that both of them stay still. So acceleration is 0, it means that F net have to be 0, which means that all the forces have to balance, have to cancel each other. And that means that this one upward have to be as strong as the one that put it downward. That's why it equals the weight itself. And then we got it 25 newtons. Okay.